tailor can't change the person standing in front of them, so they change the cloth. They pin and step back and pin again, easing the pull here, taking in the slack there until the jacket falls just right. Watch what they're really doing. They hold the body fixed and adjust everything they can control until the fit is the best it can be. That one move, fit the thing you can change to the thing you can't, is one of the deepest ideas in statistics. It's called maximum likelihood. Every cut you could choose leaves the body either easy to dress or full of puckers and strain. The likelihood how probable your data is for a given cut is exactly that, turned into a number. Maximum likelihood picks the cut under which this body is the least surprising to find. The fewest puckers, the easiest fit. A pucker is just a little improbability. And notice the direction, the body, the data never moves. We vary the cut, the parameters theta, and read how well each one explains what we see. But a garment isn't one measurement. It's shoulders, and chest, and waist, and sleeve, and hem. A dozen places the cloth can pull or gape. A good tailor reads the fit at every pin, then folds it all into one verdict: better or worse. If each measurement is independent, the fit of the whole is every pin's fit multiplied together, and multiplying a dozen small numbers gets unwieldy fast. So we take logs, which turns that product into a sum. Just add up the fit at every pin. The log likelihood, the fit, tallied across every measurement, is what we actually maximize. Same answer, far kinder arithmetic. And when the misfits are bell-shaped, adding up their squared size is exactly least squares the same fit a curve fitter would draw. How does the tailor know when to stop? Each nip either eases the fit or it doesn't. They keep adjusting in whatever direction relieves the strain. That direction is the score, the slope of the log likelihood, and they stop the instant any further nip would make something else worse. Right there, the slope is zero, the likelihood equation. The best cut sits at the top, where no small change helps. That climb follow the slope uphill until it flattens is gradient ascent. It's the very same loop that trains a neural network. For the simplest fit, you don't even have to climb. A centered seam settles where the pull from one side exactly cancels the pull from the other, and that balance point is just the average of your measurements. The best center is the mean. And the room you cut for variation is the spread of the fittings themselves, how far they scatter around that average. A tailor leaves a seam allowance, a margin, and its width tells you how sure they are. A snug, well-measured waist pins the seam sharply. You'd cut it close. A loose, draping panel barely constrains anything many cuts would do, so you leave room. That sharpness is the Fisher information, how tightly the data pins the cut, the curvature at the very top of the likelihood. A sharp peak is a confident estimate. A flat one is doubt. And the more fittings you take, the sharper it gets. The uncertainty shrinks like 1 divided by the square root of the number of measurements, settling into a tidy bell. But snug isn't always good. Give the cloth enough darts and seams, and it will hug every lump today's lunch. A slouch, the wrinkle in the shirt, beneath fitting the noise as faithfully as the shape. That's overfitting, a cut that flatters this fitting and fails the next. Here is the tailor's blind spot. Maximum likelihood has no taste, it fits whatever you give it, as snugly as the cloth allows. A master smooths the lumps, fitting the silhouette, not the noise. And the cure has a name. Bring a house line, a prior belief about what a body should look like, and let it pull the cut back toward sense. And you're no longer doing pure maximum likelihood. You're doing maximum, a posteriori map, the likelihood, times a prior. The prior is the tailor's taste. Now dress a whole crowd, not one body. You could cut one size for everyone off the rack, ignoring how people differ. You could draft a fresh pattern for each person from scratch, fully bespoke, but with only a few measurements each. Every pattern overfits. Or do what a good house does. Start from a block, a master cut learned from everyone, and alter it for each customer. The block is the population, the fixed effect. The alterations are each person's departures from it, the random effects. You borrow strength across every body while still honoring each one. That third way is nonlinear mixed effects estimation, non-MEM. Monolix, NL Mixer 2, Pumas, and when a customer offers only a few measurements, the tailor trusts the block more and pulls their alteration back toward it. That pull is shrinkage. The sparsest fittings lean hardest on the crowd. Step back. The jacket falls clean, no pulling, no gaping, a sensible allowance, the house line intact. Every choice was the same choice. Made well, pick the cut under which the body is least surprising and know when to stop. The body was your data. The cloth was your model. The fit was the likelihood. The whole craft was reading one from the other. Body the data, cloth the model, theta, fit the likelihood. The climb to where no nip helps the score at 0. The allowance the information, your confidence, the house line the prior, the block and its alterations, the population and the individual. 7 threads, 1 fit, and that's the whole of it. Maximum likelihood is a tailor. With no taste, it fits whatever you give it, as snugly as the cloth allows. Good fitting is knowing when to stop. The jacket hangs finished, but 2 questions linger. How sure is that fit? How much could the next customer's measurements shift it? And what if, before the first pin, you already expected a certain shape? Give the tailor a memory, a taste of its own, and you've left maximum likelihood behind. But that is another fitting, another evening.